In this video, I am going to solve this problem where it's given that f of y is equal to 1 half times 3 to the power y plus 3 to the power negative y, and g of y is equal to 1 half times 3 to the power y minus 3 to the power negative y. Given these two functions, we need to show that f of y plus z is equal to f of y times f of z plus g of y times g of z. To solve this problem, we are going to show that left hand side of the desired equation, which is f of y plus z, is actually equal to the right hand side of the equation. So let's start off with the left hand side, f of y plus z. Now what we are going to do, we are going to apply the given definition of f of y. So here is the definition of f of y, which is 1 half times 3 to the power y plus 3 to the power negative y. So what we are going to do, we are going to take this definition and rewrite this as f of y plus z. So what it is going to be, instead of y, look here I have y, I'm going to replace it with y plus z. So it's going to be 3 to the power y plus z plus 3 to the power negative y plus z. This is what we are going to get. Now let me label this as my equation number 1, and then let me do a little bit of explanation on how I get this function. It's important for you to understand what's going on here. So think of function. If you have a function f, it takes an input x, it gives you an output f of x. Okay, and in our case it takes an input y right here and it gives you an output f of y. Now what if I replace this y by y plus z? So I am replacing this by y plus z. Naturally it's going to give me f of y plus z. Think of this as this way. You are giving an input, it gives you a unique output right there. Now the input happens to be y here or input happens to be x here, but here in this case input is y plus z. You should think about this as a single unit, like x, a single unit going into the function, or y, a single value or single thing going into the function. So don't be confused by the y plus z. Just think of it as just one thing going into the function. So we have to replace the y by y plus z, or replace the x by y plus z. So that's exactly what I have done here. My input to the function is y plus z, and I'm gonna replace in the definition of the function y by y plus z. So look here, instead of y I put y plus z, instead of y I put y plus z, and the signs are as usual. So this is very important for you to understand. This is basically function definition, but applied in a sort of different situation, or rather a bit slightly complex situation. Now let's go ahead and play around with the right hand side, which is f of y times f of z plus g of y times g of z. To simplify this one, all I am going to do, I am just going to take the definition, f of y definition and g of y definitions, and then just straightforward apply it to them. So f of y is going to be my 1 half times 3 to the power y plus 3 to the power negative y times f of z. Now remember, when I am finding f of z, I am just basically replacing the input y by z. So it's going to be 1 half times 3 to the power z plus 3 to the power negative z plus g of y. So g of y is defined as 1 half times 3 to the power y minus 3 to the power negative y times g of z. So I'm going to replace y by z is going to be 1 half times 3 to the power z minus 3 to the power negative z. That's what it is. Now let's go ahead and simplify it further. look, there is a 1/2 here, 1/2 here being multiplied. So that's going to give me 1/4, okay, times 3 to the power y plus 3 to the power negative y, okay, times 3 to the power z plus 3 to the power negative z. Similarly, 1/2 times 1/2 is 1/4 on the right part of this expression. So it's going to be 1/4 times 3 to the power y minus 3 to the power negative y times 3 to the power z minus 3 to the power negative z. Now I'm going to just simplify it using distributive property. But before I do that, look, I have a 1/4 here, 1/4 here. So I could just factor that one out, okay? So I'm going to factor out 1/4. Now I'm going to put a square bracket. And I'm going to use two different colors for these two different parts. So these two different factors, this one and this one. So let me use red for the first one. I'm going to use distributive property here. So it's going to be 3 to the power y times 3 to the power z. It's going to be 3 to the power y plus z. Remember the formula for exponents or rule for exponent. If you have a to the power m times a to the power n, that is going to be a to the power m plus n. And that's the rule I have used. Now 3 to the power y times 3 to the power negative z, that's going to give you here plus 3 to the power y minus z. Now I do the same thing, 3 to the power negative y times 3 to the power z is going to give me 3 to the power negative y plus z. Then finally 3 to the power negative y times 3 to the power negative z is going to give me 3 to the power negative. I'm going to factor out the negative y plus z. Now let me go ahead and do the other one. So this one is going to give me 3 to the power y times 3 to the power z. That's going to give me 3 to the power y plus z, okay? Then 3 to the power y times negative 3 to the power negative z is going to give me negative 3 to the power y minus z. Now negative 3 to the power negative y times 3 to the power z is going to give me negative 3 to the power negative y plus z. Then negative 3 to the power negative y times negative 3 to the power negative z is going to give me a positive 3 to the power negative y plus z. Please do keep in mind, in the entire process, I have used just this formula, okay? Now I can simplify and cancel things. So I have 1/4 here and put it under square bracket for simplicity. So let's see what cancel out here. So 3 to the power y minus z, this one is going to cancel out with 3 to the power y minus z because one is positive, the other one is negative. Then positive 3 to the power negative y plus z, negative 3 to the power negative y plus z are going to cancel out. And then look, we have 3 to the power y plus z plus 3 to the power y plus z. So there are two of them, right? So it's going to be 2 times 3 to the power y plus z. Then also note 3 to the power negative y plus z plus 3 to the power negative y plus z. There are two of them, right? So it's going to be 2 times 3 to the power negative y plus z. Now let me close this square bracket. Now the rest is pretty much straightforward. There is a 2 here, there is a 2 here. I could factor it out, so it's going to give me 1/4 times 2 and put it inside the square bracket here again. 3 to the power y plus z plus 3 to the power negative y plus z. And that is going to be equal to 2 goes into 4 twice, so that's going to be 1/2, right? Times 3 to the power y plus z plus 3 to the power negative y plus z. That's what we get if we simplify the right hand side, okay? By the way, look at equation number 1. This is the same as this, right? Which is nothing but f of y plus z. That's what it is. So we just showed that left hand side, left hand side, which is this one, is actually equal to the right hand side, which is this one. That's what it is. Basically, we use the function definition to simplify the left hand side, which is f of y plus z. Okay. Then we took the right hand side, which is this, and we simplified it all the way and came up with f of y plus z. And that's how we solved this problem. I hope that this discussion was helpful. Thank you very much.